Ladies and gentlemen, today's topic is all about slope and similar figures, and we've talked a little bit about this in the past, but I want to explore it a little bit more conceptually. And we're going to talk about some things about similar figures that you probably haven't really heard a lot about before. So slope and similar triangles. The date is December 10th, 2013, and I'm pretty sure you should be on page 55. If I'm wrong about that, please let me know kindly, and we will fix that. But I think that's where we're supposed to be. Our objective is I understand how similar triangles can help explain the concept of slope. And really what we're looking to explain is the fact that slope is constant in linear functions. Okay, so when you have a linear function, the slope will be the same no matter where you are on the graph of your line. All right, so to dive into this, we are going to kind of make a proof for constant slope, and let's separate that into things we know and things we need to know. So before I taught you about slope, you should have known a little bit about similar triangles, hopefully. The things you should have known is that similar triangles or similar shapes are going to be the same size, same shape and different sizes. Okay, so I might have triangle A and then triangle B, and they're the same shape, but one is bigger than the other. You also need to know that the side lengths on our similar triangles are going to be different, but that they will be in a proportional relationship to each other. And in similar triangles, you need to know that all of the angle measurements match up with corresponding angles on the other triangles. So there's one triangle, there's another, and what that pretty much means is that this angle matches this angle matches this one, and this angle would be equal to this one. So maybe this angle is 110 degrees. Well, then this angle is 110 degrees, even though it's a smaller shape, because the angle describes the relationship between this side and this side. So it's okay for it to be the same degree measurement. Now, things you need to know in order to understand the proof that I'm about to show you. You need to know that if you want to prove that two shapes are similar, one way you can do that is with the SAS theorem. And SAS stands for side, angle, side. And pretty much what that means, if two pairs of sides in a set of triangles are proportional and the angles between the sides are equal, the triangles are similar. So let's go ahead and look at some triangles made from a graph. This will be on page 56. You don't have to write this part here because I'm going to print that off for you, but please do leave about the top half of the page open to tape this in. So if we look at this line, I have the line of a linear function right here. And I am going to use the side angle side theorem to prove that these two triangles are similar. And then we're going to use that to prove that the slope is constant. So side angle side theorem says if I have two sets of sides that are proportional, so let's set up a proportion. I'm going to take the 10 here, and it matches up with the 6 over on this side. So my first fraction is 10 over 6. And then I have the 5 here and the 3 here. So that is going to be my second fraction. And if I want to test if these are proportional, I have to find my cross products. 10 times 3 is 30, and 6 times 5 is 30. So because my cross products are equal, these are proportional. Okay? They are proportional. Now, the other part of the side angle side theorem says that the angle in between those sides has to be equal. So I'm talking about this angle here and this angle here. And there's something I want you to notice about these angles. When I make this triangle from my horizontal line and my vertical line, these two lines, the two sides, are perpendicular to each other. And anytime you have two perpendicular lines, the angle between them is a right angle, which we know is 90 degrees. So on both of these triangles, that corner angle is 90 degrees, the angle between the sides that I use to check for proportionality. So because the angles are equal and the sides are proportional, I know that these triangles are similar triangles. All right, so we have proven that the two triangles are similar. But my question is, how does that prove the slope is constant? If you remember, slope describes the angle of a line. I'm going to erase this part right here. Do not erase what you have in your notebook. I just need a little bit more room without going on to the next page. So this should still be written on page 56. Okay, where was I? All right, so slope describes the angle of the line. And since we have just proven that these two triangles are similar triangles, we know that corresponding angles are equal. So this angle here corresponds to this angle. My angle for both triangles is equal because they are similar triangles. In the same sense, I can look at this angle here, and I know that it corresponds to the angle on this triangle, and that they are equal. So once again, the angle is equal. So if slope describes the angle of the line, and here, if slope describes the angle of the line, and the angles are equal, then what must we know about, what am I doing? If slope describes the angle of a line and the angles are equal, then the slope must be equal. The slope must be equal. So I've just proven that when you have a line, a linear function, the slopes of those functions are going to be equal because I have proven that the triangles are similar, and in similar triangles, the angles are equal. And if slope describes the angle of a line and the angles are equal, then the slope must be equal. All right, guys, so that's it. Now, for your reflection, I want you to try and explain in your own words, in sentences, how an understanding of similar figures can prove constant slope in a linear function. So you're pretty much going to put what I just showed you into your own words and type that into Edmodo. All right? Good job, guys. I'll see you tomorrow.